Welcome to the third and final R video module. In this session, we'll be reviewing the problems from the third set of R/deducer exercises. And as before, we'll be working with the same data set, mock class data, which is provided to you in Excel format on the class website. So I'm going to start off by opening Deducer and loading the data. So again, we have our two familiar windows here, the console window and the data viewer window. And I'm going to click on Open Data and navigate to where I saved our data set on my computer, which happens to be on the desktop. And I'm going to wait for R to load the data. Great. So now that the data has been loaded, and I've checked to make sure that everything looks correct, which it does, we're ready to begin the exercise. The first question asks for the Pearson correlation coefficient between the variables politics and Obama. It asks us about the p-value for this correlation coefficient, and it also asks us to draw a scatter plot for this data. So the way I'm going to do this is to go to Analysis, Correlation, and I'm going to drag over both politics and Obama into the variables box. I want to point out that the box below it will correlate that variable with all the variables in the box named variables. So for example, if I put in, let's say as an example, varsity, it would correlate varsity with politics and varsity with Obama. Okay, so that's another option for you to use if you want to. So I want a scatter plot, so I'm going to go to Plots here. I'm going to select Scatter Plots, and I'm going to unselect Common Axis. I think it's actually a little bit easier to interpret when you don't have a lot of variables correlating with each other to not have a common axis. So then I'm going to hit OK. I'm curious about what options has, so I'm going to click on that now. I see that it has options for different sets of output that we want. So this has options for whether we want a two-sided p-value or a one-sided p-value, at what confidence level we want our output to be set at, and then of course the n, the confidence interval, the test statistic, and the p-value. We want all of these in our output, so I'm going to leave them checked. Pearson's correlation is selected by default, so that's good, and we are ready to run our test. So you'll notice a few things happened here. First of all, Deducer generated a few scatter plots for us. And then we also have our output on the left-hand side in the console window here. I just scrolled up a little bit to see it. So a few things to notice. The output is structured to correlate with the scatter plots on the right-hand side. So you'll notice that the data for let's say Obama being on the x-axis and politics being on the y-axis is in the upper right-hand corner of the output, and that same scatter plot is in the upper right-hand corner of the correlation array on the right-hand side of the screen. So that's how to read this. And so what we're interested in is looking at the correlation coefficient. The correlation coefficient is 0.7789. The p-value is very low, so low that it's in fact expressed as 0.0000, suggesting that it's extremely significant. And the scatter plot also reinforces this by showing a marked dependence between the two variables. Please note that the graph in the upper right corner gives you the same R value, p value, and graph as the figure shown in Unit 8, Slide 12. So this is one way of replicating something that you saw in the lecture slides. So the second question asks us to do another Pearson correlation coefficient between two different variables, math love and writing love. So let's do that. So the first thing I'm going to do is just close this plot. I'm going to go to Analysis, Correlation again, and uncheck politics and Obama, and replace that with math love and writing love. I'm going to bring those two over. Pearson's is great. I don't need a scatter plot this time. So I'm going to unselect that, and then I'm going to leave the options as we had them before. Then I'm going to hit run, and I'm going to look at our output. So the correlation coefficient in this case is 0.1303, and it has a high p-value this time, meaning that it is not statistically significant. Notice that the p-value is greater than 0.05. It's 0.3936, indicating that there's no statistically significant correlation between the two variables math love and writing love. So the next question, question 3, asks us to check the normality assumption of Pearson's correlation coefficient. So it's asking us to check the normality for the variables that we've used so far in this exercise: math love, writing love, politics, and Obama. And the easiest way to do that is to plot these variables and to look at the distribution to see if they're approximately normal or not. So the way I'm going to do this is to go to Plots and select Plot Builder. And I'm going to bring down histogram. And I'm just going to look at each variable one by one and to comment on the distribution. So Obama looks okay. It looks skewed on the left-hand side here. So that's something to keep in mind. Then looking at politics. Politics looks a little bit bimodal, with a peak here around 40 and another peak here around 80. So I'm less excited about politics here. Math love, let's see what that looks like. Math love, I think, looks okay. It looks the most normal out of all the variables that we've looked at so far. And then finally, let's look at writing love. And again, writing love looks a little bimodal, with a peak around 20 and another peak around 70 or so. So I don't think that we violated the normality assumption egregiously, but there could be an argument made that a different test or a different kind of correlation coefficient could be used based upon the fact that our variables aren't exactly normally distributed. Question 4 asks us to perform a linear regression of President Obama's approval scores versus students' impression of the new healthcare reform law. What are the values for the beta and the intercept? Are they statistically significant? What's the value of R squared? So a lot packed into this question, but very little that we need to do in R to answer them. And so what I'm going to do is first exit out of Plot Builder, and I'm going to go to Analysis Linear Model. That's going to give us the linear regression. The outcome that we want to look at here is President Obama's approval rating, and so we're going to select that as the outcome. The numeric variable that we're interested in is healthcare, and I can hit continue now. And we're not interested in effect modification or interactions of any kind, so I'm going to skip this screen as well. And the linear regression output comes in its own special screen. It's not in the console window. I'm going to scroll down to look at what I'm interested in, which are the values for the coefficients, the estimates for the coefficients. And we see that the intercept is about 55.25. The beta is 0.3182. Both are statistically significant. And the R squared value, a little bit below that, next to multiple R squared here, is 0.15 with an F statistic of approximately 8.2. Question 4 asks us to perform a linear regression of President Obama's approval scores versus students' impression of the new healthcare reform law. It asks us what the values for the beta and the intercept are, as well as whether they're statistically significant, and the values of the R squared for the linear regression as well. So that's a lot packed into one question, but it's actually very little that we have to do in Deducer to get that output. So the first thing we want to do is run a linear regression. So I'm going to go to Analysis and select Linear Model in order to do that. The outcome variable that we want here is Obama, which represents President Obama's approval ratings in this cohort. And I want the independent variable to be the attitudes towards his healthcare reform law. So I'm going to drag that over into the as numeric box. And then I'm going to click continue. And then since I'm not interested in interaction or effect modification, I'm going to continue. And here we have our linear regression output. Notice it's not in the console window, it's in its own window. In order to get at what I'm interested in, I'm going to scroll down. And here I see the different coefficient estimates. So the intercept is about 55.25. The beta estimate for healthcare is 0.32. And they both have a p-value of less than 0.05, meaning that they're statistically significant. But what does that really mean? So that really means that healthcare is associated with President Obama's approval ratings in this cohort, and that for every 1 unit that President Obama's approval ratings increase, the attitude towards healthcare, the unit for healthcare, goes up by 0.31. So that's what that's really saying. The R-squared value, which is listed a little bit below that, is 0.1542, and the F statistic is listed as 8.2, which is significant. The next question asks us to do something similar, but add in one more variable into the regression. And one reason we might do this is if we think that the relationship between someone's attitude towards the healthcare reform law may be confounded by something. So maybe it's not a real association, and that association, or rather that observed association, is driven, in fact, by some other variable. So to do this, first I'm going to exit out of this. The question asks us to include the new variable politics, essentially, the student's political bent, and repeat what we just did. So I'm going to go to Analysis and Linear Model. I'm going to drag Obama into the outcome box, and the healthcare variable into the as numeric box, but also politics into the as numeric box. I'm going to click continue, and again, we're not interested in interaction or effect modification, so I'm just going to continue here. And our output is displayed in this screen once again. So scrolling down, a few things to notice here. So I'm going to read out the estimate. So the estimate for the intercept is 22.2, for healthcare is 0.13, and for politics is 0.62. What should be noted as different from before, first of all, is the magnitude of the intercept for healthcare. In the previous regression, the beta was 0.31, or 0.32, rather. In this one, it's 0.13, so it's greatly reduced. And second, it's no longer statistically significant. So what does that really mean? It means that the observed association between someone's attitude towards the healthcare law and President Obama was actually driven by their political beliefs. Politics here has a beta estimate of 0.62, and the p-value is statistically significant. So another way of interpreting that or thinking about that is really that the student's political beliefs, represented by the variable politics, is statistically significantly associated with their views on Obama. One other way, again, of saying that is that their political beliefs can accurately relate to, correlate with, are associated with, predict their attitudes towards Obama. Okay, and to just finish this up, the R-squared value, again, you see at the bottom is about 0.63, and the F statistic is still significant at 36.53. One other thing to keep in mind, compared to the previous regression, is that the beta estimate for healthcare changed more than 10%. So when this changes more than 10%, this suggests that there was confounding. Okay, this isn't a hard rule. It's not like there's some mathematical theory behind that, but it's more of a rule of thumb that when the beta estimate changes by more than 10% after adding in another variable, that that observed relationship previously was due to a confounding factor. The last question in this data set asks us to do another linear regression, but this time instead of using a continuous variable as our independent predictor, we're going to use a categorical variable. That variable in this case is varsity, which happens to be binary, 0 or 1, but that's still two categories, and we're going to be using dummy coding to run this regression, which is a bit of a departure from what we've been doing before with our continuous independent predictors. So the first step, as before, is to click on Analysis and select Linear Model for our regression. The dependent variable we want in this case is exercise, so I'm going to move that into the outcome box. And I'm going to move varsity into the as factor box. Now before we were moving everything into the as numeric box, that was for continuous variables. When we want to treat something as a factor or as a categorical variable, we're going to move that variable into the box labeled as factor. Okay, and then I'm going to click Continue. We're not interested in effect modification or interaction at this point, so I'm just going to click Continue and scroll down to look at our results. So a few things here. So the beta estimate for our intercept is 3.57. The beta estimate for the variable varsity is 0.975. The R squared is 0.03, and the F statistic is 1.5. The F statistic is not significant. Probably the most important thing in this output is the p-value in the row for the varsity variable. It's 0.227. It's not statistically significant, which means that our conclusion is that varsity is not statistically significantly associated with the amount of exercise that you have right now. So that concludes this third exercise and this third R video module.